A warm greetings to all. Welcome back to another video on our Java series. In our previous video, we were talking about encapsulation. You can see the same example that we have dealt with earlier. In this video, we will be discussing about the next pillar of hooks, that is polymorphism. For that, I will just clean up this code a bit because or else it might become a bit confusing. I will remove the unnecessary methods from here. Yeah, all those are removed. Now we are having a simple class parent which is having properties like age and name and functionality called think function, which enable my parent to think. And as a child, what am I doing? I am inheriting all those properties and behavior. So I will be exhibiting all those properties and behaviors, which means that I will be inheriting his capability to think. So if I execute this, yeah, it has been successfully inherited. But now let's go a bit deeper. Let's look into the perspectives of our parents. Let's see how they think. So if it was a live class, I would have asked you to share some perspectives, but for now, I will just come up with something. Let's say that as a parent, he will be thinking something like study hard, get a job, get married, have a family, etc. Okay, so as a parent, he is thinking something like you have to study hard, you have to get a job, you have to get married, you have to have babies, and etc. 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 So these are the thoughts of your parents. But due to inheritance, what is happening now? If I try to print this think function as a result of inheritance, not just his capability to think, but also his perspectives will be inherited by me, which means that I'll be thinking in the same pattern. Study hard, get a job, get married, etc. etc. So the same thing has been inherited by me, the child. But as a child, I will be having my own perspectives, right? You guys will be having your own perspectives. Everybody will be having their own perspectives. So I need a way by which I should be able to inherit the capability to think from my parent, but I don't want his perspectives. I want to have my own perspectives. So what can I do for that? I will definitely inherit his capability to think. But what I will do is that I will override his perspectives with my own perspectives. Alright, so I have inherited his capability to think, but what I did was that I'm going to override his capability. What I did is that I'm going to override his perspectives with my own perspectives. That is, let's say that for now I can just stay with study. I'm not putting the hard there. Study, find your purpose, marry when it's time, start a fam when it's time, etc. Alright, so these are my perspectives that differ from my parents. Alright, so I wanted his capability to think, so I did do the inheritance part, but what happened here is that instead of his perspective, I needed my own perspective. So after inheriting it, what I did, I have overridden that with my own perspectives. So now when I execute the code, what happens? Instead of his perspectives, my perspectives will be printed. Study, find your purpose, marry when it's time, etc. And this capability of a method to exist in same name but perform different functionalities, that is termed as polymorphism. The capability of a method to exist in same form but perform different functionalities, that is termed as dynamic polymorphism. And this polymorphism has been achieved by method overriding. This has been achieved by method overriding. And this is also termed as dynamic polymorphism or runtime polymorphism. This is because the compiler makes a choice between these two think function during runtime. That is why it is termed as dynamic polymorphism, and you have seen by yourself that this polymorphism has been achieved by using method overriding. And by the way, this override is an annotation used in Java. Even if you are not using it, it won't cause an issue. It won't even throw a warning. It won't do anything. It will just print in the way that it has printed before. When I execute it here, you can see that it is still printing my perspectives. It has been overridden, but still it is preferred to give a annotation here. Okay, so we can give a heads up to the compiler that okay, this thing function is being overridden. We are just saying that to the compiler. That's it. Other than that, they won't do anything special here. Even if you neglect it, it won't be going to cause any problem there. But it's a best practice to go ahead with it. All right. Also, at a later point of time, when you are going through this code and when you see this annotation, you will know to yourself that okay, this method had been overridden. That's the basic idea. All right. So this is polymorphism. So we have talked about dynamic polymorphism. So if a dynamic polymorphism exists, then definitely there would be a static polymorphism. So static polymorphism, I will just show you a simple example and narrate it to you. So let's consider that for this class tester, I am going to introduce a method called add function. All right, void add function, and I am going to introduce one more method, void add function. So this add function is accepting an integer variable, whereas this add function is accepting nothing, and within here I am going to print something like sysout1, and for my second add function I am going to print 2. Okay, so this is my thing, and within the main method what I am going to do is new tester function dot add function. So now what you have to do is that guess what will be the output in this case. In line number 34, I am making a call towards the add function. So my question is, which of these add functions will be executed? What will be the output in the console? 1 or 2? Definitely 2, right? So when I execute this, the answer is 2. Why? Because if you have found the answer, you know the process, right? So here I am calling an add function without passing any values. And within the tester class, I have two add methods, one of which is accepting a single integer value and another one which is not accepting any values. And since we are not passing any values, the compiler will match that with the method add function which is not accepting any values, which in our case is this method. So that method will be executed. On the other hand, if I were to pass any integer values, let's say 34, yeah, and execute it. Now in this case 1 will be printed. Why? Because my compiler will go ahead and match this method call with the method which is accepting a single integer value, which in our case is this first add method. So let's say that this method is also accepting values int a and int b. In this case, which will be matched? Again, the first method will be matched. Why? Because we have two methods, one of which is accepting a single integer value and another one which is accepting two integer values. So if I am passing two integer values using my add method, then it would have matched with the second add method. But as of now, I am passing a single integer value, so this first method will be matched. And this type of polymorphism, here also you can observe that the method exists with same name but can perform different functionality, and this is termed as static polymorphism. And the difference between the method will be defined or found out or evaluated at the time of compilation itself. That is why if I am giving the same argument numbers, it is throwing an error. Why? Because at the compilation time itself the difference will be evaluated, and this is termed as static polymorphism or compile time polymorphism, and this is achieved by method overloading. So method overloading is the process by which we will be defining methods with same names but having a different number or type of arguments. I mean, I can have same number of arguments but one of them can be float. So here the type of the arguments are different. right? So if I execute it, it will be matched to an add method which is accepting an integer value. That is our second add method. Alright, so that is method overloading. Method overloading is a way by which we will be defining separate methods with same name, but they will be having different number of arguments or types of arguments. Okay, and the polymorphism achieved by using that method overloading process is termed as static polymorphism, whereas dynamic polymorphism is achieved by the process of method overriding, that is achieved at the time of inheritance. So that is the concept of polymorphism. With that, I hope the concept of encapsulation and polymorphism is clear to you all. If you have any doubts, please feel free to ask. I guess that's it. That's all I got for this video. I hope you guys were able to understand and learn something new from this video. I hope it was beneficial to somebody out there. So until next time, it's your friend Sajin, and we will meet in our next video.